Thank him sincerely for organizing this webinar today. Computers have long become part and parcel of our life, and human existence would be in a problem without its aid and use. As far as I have understood, today's webinar related to is something which enables computers to understand natural language as human beings do. NLP uses artificial intelligence to take real world input, process it, and make sense of it in a way a computer can understand. AI is a call of the day and our future. So, looking forward to the talk of Dr. Shantanu Modak for enlightening us on this aspect in details. And I really thank all the faculty members, our principal sir and president sir for being with us always in order to continue with our effortless work. Thank you and over to Shamoresh.
Thank you, ma'am, for your deliberation. Now the time has come to today's main attraction, a discussion on pre-processing of text data using natural language processing. We are extremely happy to have with us Dr. Shantanu Modak as chief guest for the occasion. Now I introduce little bit about Dr. Shantanu Modak. Dr. Modak is from Bolagar, Bardhaman. After schooling, he completed his graduation in computer science from Sri Augustine College under University of Calcutta. He completed his MSc from University of Burdwan. He was awarded with a doctoral degree by the University of Burdwan in the domain of machine language. He started his career as faculty of computer science at Asutosh College, Kolkata, and served the college from 2nd January 2015 to 31st January 2023. Later, he shifted to St. Xavier University, Kolkata as an assistant professor on and from 1st February 2023 till date. His research interest is in the sentimental analysis, text classification, and machine learning. Now I request Dr. Modak to deliver his valuable speech on today's topic. Thank you, Dr. Modak. Now hand over to Dr. Modak.
Thank you, Mr. Samoresh Pramanik, for nice introduction. I am also thankful to Gaurmon Sachin Mandal Mahavidyalaya College Authority to giving such opportunity to deliver my speech on natural language processing. Obviously, natural language processing is not a new technique for a computer scientist, but it's a very interesting technique for other domain people. So today, let me discuss about the data first. Mm, So, what is data? If you consider data, then what is in our mind? We may have some Excel sheet. There are certain kind of data. All can be numeric data or text data. Like if we have some employee table, so employee name can be there, employee code can be there, basic pay, grade pay, salary to a gross salary can be there. So data can be this form. And this type of data, if you go back to 20 years, so all data are on that type. But now, in today's world, data concept is little bit different. Every time, what any activity we do through internet means we are generating data. Suppose we are writing something on Facebook, on Instagram, or we are searching something on Google, even in e-commerce site also, means we are generating data. Whatever we searching in e-commerce website or any social media site, we write in text format. So concept of data becomes different. That time data came in Excel format, Excel sheet format, like CSV format. And now data came into picture like text format, audio format, video format, image format. So the data is now unstructured data. Why it's called unstructured? Because suppose I want to write I am fine. So instead of writing I am fine, I can write I am fine, F9. So total structure of data is different in human talking language or in terms of natural language also. So processing of natural language text is little bit difficult for machine. Today I am demonstrate one by one technique how a natural language text can be processed through machine. Okay, and today's lecture is very introductory lecture. Obviously, I talked to Professor Piali Das to arrange some series of lecture to discuss in this topic. In future, if we can arrange this type of lecture, we can analysis the NLP technique in very brief. Today's lecture is very introductory lecture. So I am going to cover every pre-processing tasks of text data using natural language processing. So let me share my screen. And student participant, if you have any question, you can ask in Bengali also. Is the screen is visible?
Yes, it's visible.
Yes, it's
Yes, visible.
Visual. Yeah.
Yes. So if we think natural language processing, it's a branch of artificial intelligence. So you can consider artificial intelligence is a broad topic. And natural language processing also can be a part of artificial. If you consider this is complete AI, so NLP can be one subset of AI. Okay. So several other things also are available in artificial intelligence. So NLP basically focus how to enable your machine, means your computer, to understand, interpret and generate human language. Now you know chat GPT already came into picture, which is concept of open AI. Chat GPT not only understand your query, it also generate human language text that provides the answer to your query. So natural language processing must include not only understand or interpret the data, it has to generate the data in human language. But in case if you consider the subject computer science, obviously the main part, linguistic also the part of the natural language processing, because I know several linguistic researcher who doing research in natural language processing. They find the linguistic technique for natural language processing, and computer scientists develop the algorithm and code to manipulate the natural language data. So the primary goal of the NLP is to create an intelligent system that can interact with human in natural language. I think all of us already use the chat GPT like site where you can give a query and the bot will give you the answer. And before chat GPT, you can consider chatbot was one application, famous application of natural language processing, where we can type a query and chatbot give us answer. So it not only just language translation, sometimes it also used to detect the sentiment analysis. Sentiment analysis means suppose when we want to write a review or when we want to write a text in Twitter, means tweet data. So we are mm, providing a particular sentiment. Suppose if I buy a particular phone from a e-commerce website, after using the phone, I can put a review. Based on the review, the company can understand what's the fault, how people react about their phone. So sentiment analysis is very interesting research topic in natural language processing in for business world. Judging if 2,000 or 5,000 customer already put their review in e-commerce website. So it's not a easy task for a human to analyze all the review and to make a judgment what are the faults in their application. So by using some machine learning technique, natural language processing technique, they can understand about the people's sentiment. Speech recognition is also the part of natural language processing, and some better version of speech recognition is text to speech conversion. Sometime you already use the speech to text conversion in Google search, so that is also part of natural language processing. So it involves analyzing large amount of text data. Text data means the data is unstructured data. If you consider data in a tabular form, that time you can say data is in structured format. It can be Excel data, it can be Microsoft Access data, or SQL table like data. That time data is the structured data. But if you take the data as a text data or image data, video data, that data is called unstructured data. So processing of unstructured data needs some pre-processing tasks, and pre-processing tasks will convert your unstructured data to structured data. Obviously I will not discussing any mathematical problem how to convert unstructured data to structured data, but I will give some very basic pre-processing task idea. By using the idea, you also can pre-process the natural language text. So there are several steps involved: tokenization, parts of speech recognition, named entity recognition, sentiment analysis, machine translation, all are part of natural language processing. So when natural language processing actually implemented, first application is chatbot-like application, some voice assistant, some search engine, social media monitoring tool. Everywhere in today's world, everywhere a natural language processing is implemented. So processing natural language data is more important than processing the structured data. So there are several steps involved in natural language processing. If you because all data are text data here, so you have to pre-process the text, because from the very early age of our life, we know one the interesting sentence: computer can understand only 0 and 1. I think all of us already aware of this sentence. But in case of natural language processing, or in case to consider the today's world, computer can understand only the structured data. So we have to convert the unstructured data to structured data. So there are several text pre-processing tasks involved to clean your natural language text. That may include the tokenization, stop word removal. So I will discuss one by one technique. First one is tokenization. Tokenization means it breaks your sentence into smaller unit called tokens. So what is tokens? Suppose consider this sentence: I will go to Kolkata. Okay, let's take one sentence for better understanding. Suppose the sentence was, I will go to Kolkata. This is a particular sentence, but after tokenization, it's all words or all alphabets will remain here, but it break the sentence into tokens. Like I will be a different token, will different token, go different token, to different token, Kolkata different token. So after tokenization, it break the sentence into stream of token. Next one is parts of speech tagging. After tokenization, if we can apply the parts of speech tagging, so it tag every token with a particular parts of speech. So when the computer scientists build the parts of speech tagging, they obviously take the help from linguistic people, because linguistic people have better idea in parts of speech tagging. So already I told that not only computer scientists involved in natural language processing, several linguistic people also doing their research in natural language processing. So parts of speech tagging is the next part after tokenization. Next one is named entity recognition. Means in this sentence, you also find one named entity that is Kolkata. So by using NER named entity recognition, your computer can understand the particular named entity which is present in your text data. Next one is parsing. Parsing means it analyzes the grammatical structure of the sentence, and sometimes it also helpful to to, to find the word sense disambiguation. Let me explain one thing, so it will be under easy for you to understand the parsing. Suppose I saw the boy with a telescope. I saw the boy with a telescope. So two different meanings can be possible. By using the telescope, I see the boy, I saw the boy, or I saw a particular boy who handed a telescope. This type of disambiguation and this type of ambiguity can be nullified by using parsing. There are several algorithms available in parsing for word sense disambiguation, and also ambiguity is present in natural language. So word sense disambiguation also a very good research topic in natural language processing. One Hindi example just I remind. So if you break this word from here, so it will be a jayenge, means will come. But if you break from here, aaj aayenge, means to he will come today. So two different meaning also possible in this particular Hindi word. Next one is sentiment analysis. Sentiment analysis already I told you, by reading a particular review or by reading a tweet, we can judge the proper sentiment of a writer. But when we want to analyze 1000 or 2000 reviews at a time, so it's very difficult for a human to judge to study all the review and to find a particular decision about the review. So we have to use the machine learning algorithm for sentiment analysis, where machine can understand the particular sentiment, it can summarize the review, and it can give you some fruitful result about your product or about a particular event. So last one is evaluation. Evaluation means it will evaluate your algorithm, how it looks good. Several statistical metrics are there like precision and recall accuracy, all are part of evaluation. Now come to the actual thing. First one is text pre-processing. So first thing is you have to remove the punctuation mark from your text data. Suppose you have a text data, you have to remove the punctuation mark from text data, and you have to convert all your text data to a lowercase. Why lowercase? Because if your algorithm become case sensitive, so it will treat this it will treat this word and this word different word. It will consider these two word are different word. So you have to convert your total text data to a lowercase. So it will be easy for analyzing, it will be easy for understanding. So first thing is to remove the punctuation and convert your whole data to a lowercase data. So how to convert it? A famous automata technique is there that is called regular expression. So you can use the regular expression by importing the RE module in your Python tasks. Okay. So let me show a particular code. Import RE. So just taking the import RE, all regular expression feature will be implemented here. Now you consider this text, hello world, how are you? Then you have to use the function clean text, and this is the particular regular expression which remove all the punctuation marks from your text. Okay, and it will print a clean text. Several other techniques are there. Next one is string translation. By using string translation, you can also clean the text. You can also remove the punctuation mark from the text, and this is the particular code for strings translation. You can try the code. I will send you the PPT. You can try the code in Python module. So you may have one question: why we use Python? So several other languages are there like C, C++, Java. So why we using Python? Because Python is an interpreter-based language, and all other language like C++, Java, that are compiler-based language. So doing these tasks in Java, we have to write at least 40 to 50 lines code. And you can see within 5 lines code, the same thing can happen in Python. That's why the NLP researcher especially like this language Python. And one technique was regular expression, another was string translation, and next one can be the NLTK library. It's a famous library that is available in Python. So to import the NLTK, first we have to write one command, import NLTK, then NLTK dot download punct. Punct is a particular tokenizer which can tokenize your text data. Then this sentence from nltk.tokenize import what tokenize, so it will break your text into stream of token, and it will eliminate every punctuation mark from your text, and it will print a clean text. Okay, so I think this first technique is understandable to you. Next technique is convert to lowercase. So I already told you that we will have to convert all data to lowercase, because if your algorithm becomes case sensitive, so it will treat same word differently. Okay, so you have to create a long matrix for that. So it's better to just convert your total text data to lowercase. So it's not difficult in Python. Just writing one line of code, easily you can convert your total data to in lowercase. So there are also three methods available in Python. Not only three methods, several other methods also available. So as per your need, you can use the same. First one is lower function. This is available in Python. Just using lower function, your text data will be in lowercase. Okay. So if it is your text data, just use the text.lower function. First, I have to take the variable text where I put the data. Okay, so this is for your example. You can take a particular CSV file, particular corpus for this purpose, and by using this text, your total corpus will be in lowercase. If your corpus may have 15,000, 1 lakh word, so easily it will convert it to lowercase by using a simple line of code. And if you print the text, print lower text means total corpus, not consider the single sentence. If you consider a total corpus of 10,000 to 15,000 words, so your total corpus will be converted to lowercase by using a simple lower function. That's why Python is more interesting. Okay, so you can also use the case fold method. This is also almost similar function to lower function. It will also convert your text to a lower text. So for converting text to a lowercase, two different function is available. One is lower, another one is case fold. Obviously, you can use the same NLTK library to convert it into a lowercase. So for that purpose, you have to again implement the you have to again import the NLTK library. Then you have to download the Plunk tokenizer. First tokenize, then use the lower function or what tokenize function. to convert it into a lowercase. Then by using the join, using this join, every tokenized word will be joined and it will form a particular stream of token which all available in lowercase. Okay. One minute. Is the whole thing perfectly understandable for you? If you have any question, you can ask me. Okay. So third technique will be any question?
Please go on.
Okay. So next technique is stemming or lemmatization. We can use stemming or we can use the lemmatization. Both can be used for a particular purpose, but there are certain differences between stemming and lemmatization. Both will convert your word to a root form. Okay. So stemming basically root form means suppose um, if your word is hired, HIRED. So what is the base form of the word that is hired? So both stemming and lemmatization will do the same thing, but algorithm is different in stemming and lemmatization. I will explain both in through code. So stemming basically remove suffix from the word. So it removes the D, sometime it remove the ed, sometime it remove the ies, sometime it will remove es, s. This suffix can be removed from your text data and it will return a base word. But there are some problem in stemming. You can try stemming in this word like history, and if you're I find interesting in stemming, if your word is history, it will return HISTRI. Okay, so stemming basically, and in case of hired, this word, it will remove the ed from your text data and it will return HIR. So stemming algorithm, there are some regular expression which is available in stemming. If it find ed in your word, so it remove ed word from the word, ed alphabet from your word. If it find ies, it remove the ies. So sometime it can't return the meaningful word, but lemmatization do the stemming in backend. It will check with the dictionary and return a meaningful word after stemming. So sometime if the time complexity is not important, so we can use the lemmatization instead of stemming, because after using the stemming you can find several spelling mistake in your data. So after stemming, we can use the spell correction to change the data. But lemmatization is comparatively better technique. Obviously, time complexity will be higher in case of lemmatization, because after stemming, it will search every word with the dictionary word and find the meaningful word related to your text, and it will return the meaningful word to you. So after stemming, you have to do spell correction, but after lemmatization, no need for spell correction because it will give you the exact word. So stemming basically remove the suffix and prefix from your text data. There are several stemming algorithm available. One famous example is Porter stemming algorithm. So for Porter steamer algorithm, you have to import the Porter steamer in your NLTK stream. So If you want to process natural language, NLTK will be must needed library for your natural language processing tasks. So you can import the Porter Steamer into NLTK and then take a reference of Porter Steamer PS. If the text is stemming is the process of reducing a word to its base form. So first you have to tokenize the word, then you have to stem the word. So every word will be stemmed and then it will join here to make a compact array of data. Okay. So first we download the Planck tokenizer and Planck tokenizer tokenize the data. Then we apply the stemming algorithm to get the result. Now come to lemmatization. So obviously it will convert to base form, but it use some dictionary based approach and use some parts of pitch tagging for particular output. So WordNet lemmatizer is one of the famous lemmatizer which is available in NLTK. So we can use the WordNet lemmatizer to lemmatize the text and to get the word in base form. Almost I am doing the same task which is for potasteamer. See the code here. I import potasteamer and here I import the WordNet lemmatizer. And in the same way I create the reference, and by reference I join the word and make it a compact word of array. Then we can print the data. So now by using this code I am showing you what are the difference between stemming and lemmatization. First consider this code. I import lemmatizer here and import stemmer here. So what is my sentence? The quick brown foxes jumped over the lazy dogs. Okay. So my sentence is now after tokenize, I can use the stemmer and also use the lemmatizer. In the same code, I am using the thing. First, I have to import NLTK, then potastemer and wordnet lemmatizer. Now I create two reference. One is potastemer, another one is lemmatizer. So this is stemmer reference. Same sentence, I use the stemmer and lemmatizer. Now I am checking the output. In stem word, in the quick brown fox jump over the lazy dog. LAZY. So what was the sentence? LAZY. So in Porter-Steamer algorithm, there is one regular expression. Y will be converted to I. I give the previous example where I show you that history will become history, HISTRI. So in the same way, this lazy will become LAZI. Now, if you use the lemmatizer, means in this part, you can find it's become LAZY. So after stemming, actually lemmatizer algorithm break into two parts. So after stemming, it will check every word with a particular dictionary. Then it will find the meaningful word from the dictionary and it will return the meaningful word. That's why time complexity become high in case of lemmatization, but in case of stemming, obviously time complexity is low. Now, the last topic, we are reaching the last topic of pre-processing, that is POS tagging, means parts of speech tagging. So obviously, parts of speech are very important in case of natural language. In case of sentiment analysis also, parts of speech tagging is very, very important. I will show you one example. You can understand why I am saying parts of speech is so much important. So it is good, means it denotes a positive sentiment. The thing is good. So what is the adjective? Obviously, good is the adjective. By seeing the adjective, we can conclude that the thing is good. But just consider one adverb before this adjective. It's not good. Knowing just adjective is not sufficient for a sentiment analysis. Nearest adverb is also playing an important role in case of sentiment analysis. So detect the particular parts of speech from every sentence is very important for natural language processing. So several parts of speech tagger is available. Stanford POS tagger is available. It will break the sentence, the tokenized sentence, and tag every sentence. It can be noun or verb or adjective or adverb. So it label every token with a particular tag. There are a pretend model which where several data are already tagged. By using that data, it can tag your text data. Okay, so I'm using a parts of pitch tagger. So NLTK already have some inbuilt POS tagger. So for your purpose, you can use the NLTK POS tagger. So the same sentence, the quick brown foxes jumped over the lazy dogs. So first thing is we have to tokenize the sentence, then we can use the parts of speech tagging for your word, and it will print POS tags. So let's see how POS tag is look. The DT, quick JJ, brown NN, foxes NNS, jump VVD, over in, the DT. See, this the is also DT, this the is also DT. Okay. Lazy JJ, dogs NNS. So DT is the determiner A and D will be the determiner. JJ is for adjective, NN is for noun, NNS for plural noun, VBD for past tense verb, IN for preposition or surrounding conjunction, subordinating conjunction, and dot stands for punctuation. So your total text data will be tagged. And if you want to analyze the sentiment from your text data, easily we can find the nearest adjective and nearest adverb of the adjective. Okay. So these are the part of text pre-processing. I'm very summarize the pre-processing technique. So in future, if you are interested in text pre-processing, we can analyze some mathematical and statistical function to mm, show you how to implement the regular expression algorithm, how to implement the stemming algorithm. So if you are interested, you can inform. So in future, we can analyze the thing in better. So these are the reference. I already put some coding reference here. I'm not giving any research paper reference here. Okay. So because I know mm, several participants are basically the student participants. So if they can run some code, so they will be interested. You can use the code for your purpose. I already provide here several reference, several codings are available here. You can use the code for your purpose. Okay. So thank you for College Authority to provide me such a platform to deliver speech on natural language processing. Personally thankful to Honorable Principal Sir of Gaurmon Sachin Mondal Mohavidyalay, Convener Mr. Somores Pamani is also my friend, Professor Piali Das, and other college dignitaries who are present here. In future, if we got such opportunity to organize a series of lecture, obviously I will try to manage my time to deliver such kind of lecture. Now I am ready for question. If anyone have any question, they can ask me. Any question from anybody? Now over to convener.
If anyone have any question, please. ছাত্রছাত্রীরা তোমাদের যদি কোনো প্রশ্ন থাকে তোমরা বাংলা প্রশ্ন করতে পারো।
যদি কেউ বাংলায় কোশ্চেন করতে চাও করতে পারো। কারোর কোনো প্রত্যেকটা জিনিস কি স্টুডেন্টদের কাছে ক্লিয়ার হয়েছে? স্টুডেন্টরা একটু আনমিউট করে বলো।
Yes, sir.
থ্যাংক ইউ, থ্যাংক ইউ।
Thank you, Dr. Modak, for your wonderful lecture. Now, the time to vote of thanks. Now, time has come for vote of thanks. All at the very outset, I like to express my sincere gratitude towards Honorable GB President of our college, Mr. Jaydev Haldar, for his continuous support. I am extremely grateful towards our principal sir for inspiring me to conduct this program. NAC coordinator Ms. Priyali Das, IQ coordinator Mrs. Ranjini Gho, and academic coordinator Mrs. Anupama Mantri. All of them deserve the special mention for their cooperation. Thanks to Dr. Shantanu Modak, Chief Guest of today's webinar. Thank you, sir, for giving us your valuable time and sharing your ideas with our audience. We hope you will extend your cooperation in near future also. Last but not least, thanks to my colleagues and their students for their kind presence. Thank you. With this note, I conclude this session with the permission of our principal sir. Good night, everyone.
Thank you, sir.
Thank you. Good night. I'm your Akchi.
Thank you, Shamuresh. Thank you, Dr. Modak. You have tried your best to make us